the combination of sequences and series. In some questions, there are situations where there is missing information, which is completed by combining the sequences and series approach. Let's consider a couple of examples, one from each type, to clarify this point. Example 1. In an arithmetic progression, the first term is -4, the fifth term is 20 and the last term is 134. Calculate the sum of all terms in the corresponding series. Solution 1. We have the following clues: x, 1 equals -4, x, 5 is equal to 20 and x, n equals 134. Thus, since in an arithmetic series the nth term is calculated by the formula, we have the following shown on screen. We first find the common difference d, by writing, we have the following shown on screen. Now, let's find the total number of terms n in this sequence. Thus, we have the following shown on screen. At this point, we are ready to find the sum of all terms in this sequence, which represents the corresponding arithmetic series. Applying the Gauss formula, we have the following shown on screen. Let's consider another example, but this time with geometric series. Example 2. The second term of a geometric sequence is 32 times greater than the seventh one. The sum of the first 7 terms of this sequence is 254. What is the 13th term of this geometric sequence? Solution 2. We have the following clues: x, 2 is equal to 32, x, 7 and s, 7 is equal to 254. These clues help us find the common ratio r first. Thus, since in a geometric sequence x, n equals r, n minus 1 x1, we have the following shown on screen. We have the following shown on screen. More precisely, we have the following shown on screen. And, we have the following shown on screen. Dividing the equations yields, we have the following shown on screen. Simplifying x, 1 yields, we have the following shown on screen. Inverting down both sides yields, we have the following shown on screen. Since x, 2 is equal to 32, x, 7, then, we have the following shown on screen. Thus, we have the following shown on screen. Next, let's find the first term x, 1 of this sequence by the help of the geometric series formula, the second version, given that r, e1. Thus, since in a geometric series, we have the following shown on screen. And given that in the specific case s, 7 is equal to 254, n equals 7, we obtain for the first term x, 1, we have the following shown on screen. Last, we find the 13th term of the given geometric sequence by using again the formula, we have the following shown on screen. But this time for n equals 13. Hence, substituting the known values yields, we have the following shown on screen. That is all for lesson 12.2.5. To continue this tutorial, please watch 12.2.6, Combined Series. Thank you for watching. Make sure to like and subscribe to keep up to date with new videos. For more information, calculators, and tutorials, please visit www.icalculator.info.